All right, now that you've learned to balance chemical equations, we're going to start predicting the products of chemical reactions and classifying the different types of chemical reactions. First type of chemical reaction is called a synthesis reaction. It's just how it sounds. It's a synthesis of two or more reactants that come together to form a single product. So here's an example of a synthesis reaction. We have 2 sodium plus chlorine yields 2 sodium chloride. So 2 separate reactants come together or synthesize to form a single product. Second type of reaction is called a combustion reaction. This is where something reacts with oxygen, combusts, it releases a lot of light and heat. Usually the products are water and carbon dioxide, especially if you're combusting a hydrocarbon, which is something that is really common. In fact, if you burn propane in your at home when you're barbecuing and stuff like that, propane is a hydrocarbon. The byproducts of that combustion reaction are carbon dioxide and water. This is a different type of combustion reaction that's shown here, where you have 2 hydrogen plus oxygen yields water. This is also a synthesis reaction. This would be if you burn hydrogen gas, what the product would be. Oftentimes you're not just burning hydrogen gas, so you're burning maybe a sugar or a hydrocarbon or something like that. In that case, CO2 and water would be the 2 products. And I gave you a slide, a blank slide with another example of a combustion reaction. All right, the third category of chemical reaction is called a decomposition reaction. It's exactly how it sounds, and it's actually the exact opposite of a synthesis reaction. It's where you have a single reactant decomposing into 2 or more products. A lot of times, light, heat, electricity, those kind of things, oh, I'm sorry, a lot of times light, heat, or electricity are necessary to get a decomposition reaction started. All right, there are 2 categories of replacement reactions. The first one is a single replacement reaction. That's where you have a single element replacing a similar element in a compound to form a compound in the single element. So basically A bumped B out. Now A is patched with X, and B is now by itself. There are times when single replacement reactions won't take place. It has to do with what's called the activity series. So anything that's up here high on the activity series can replace anything below it, but the opposite is not true. So for example, if I have, let's say I have lithium and I want it to react it with, say, sodium chloride. It's probably a bad example, actually. Let me give you a different example of a salt here since sodium's not on this activity series. Let's say I want to react lithium with potassium chloride. Okay, lithium is higher on the activity series than, oh, there it is, than potassium is. Therefore, this reaction will take place. Lithium will go in here, it will replace the potassium, and potassium will now be by itself, and lithium chloride will be the other product. So that's a single replacement reaction. Now, this reaction would not occur. If I had potassium plus lithium chloride, there would be no reaction. The reason there'd be no reaction is because potassium is lower on the activity series than lithium, so potassium will not go in here and replace lithium. So it has to be higher than the other substance in order to replace it. This cannot go in and replace this in a compound, though. This also happens with halogens. Some halogens are more reactive than others, so they have their own reactivities, and they don't always replace each other either. But there are single replacement reactions that involve the halogens as well. So let me give you an example of a single replacement reaction with a halogen. Let's say the halogens are fluorine, chlorine, bromine, and iodine. Okay, so these can replace each other as well in a chemical reaction. So let's say I had potassium fluoride plus chlorine. Okay, this chlorine can go in here and replace this fluorine, and that's a single replacement reaction as well. All right, the next category of replacement reactions would be a double replacement reaction. This occurs when we have two compounds and they switch, basically the metal ion switch places or the positive ion switch places, or you could even look at it as the negative ion switch places. So they're showing you a generic equation, AX plus BY yields AY plus BX. So the X's will switch places and the Y's will switch places. So basically new partners. So here is a compound, calcium hydroxide, hydrochloric acid is a compound, calcium can bump out hydrogen here, then chlorine and hydroxide will switch places. And so what we end up with is calcium going with chlorine and hydrogen going with hydroxide. And it rearranges, the H, you don't write it as HOH, you write it as water, H2O in that situation. Um, a lot of times these double replacement reactions produce what's called an insoluble product, and that's known as a precipitate. It's one of your indicators that chemical reaction has taken place, and it's a solid product. So you would have two clear liquids, you mix them together, and a solid product comes out of solution. That's a precipitate, and we'll see that when we do our chemical reactions lab. All double replacement reactions produce either water, a precipitate, or a gas. So this table here shows some steps to writing double replacement reactions, and we're going to go through this in detail together in class. And I'm actually going to do this on a separate recording. I'm going to show you how to write these double replacement reactions.